In our previous meeting, we discussed on how to solve right triangles, wherein we use Pythagorean theorem. We also use the trigonometric identities in order to solve right triangles. But in some cases, the given is not a right triangle. So with that, we cannot use those formulas. So if the given is not a right triangle, we have a different way of solving it. And that is our discussion for today, which is about solving oblique triangles. When we say oblique triangles, we are referring to triangles which are either acute or obtuse. And one way of solving them is by using the law of sine. The law of sine can be represented by this formula, wherein uppercase letter or capital letters are angles, while lowercase letters or small letters are the sides. So here, we are just taking any pair of the formula, whether we have sine A over A equals sine B over B, or sine B over B equals sine C over C. It depends on the given side and the unknown side, or it depends on the given angle and the unknown angle. In other references or other books, the representation of the formula may be the reciprocal of the given formula here. So in other book, you may find A over sine A equals B over sine B equals C over sine C. But they are the same. So it's up to you. Either you will use the first formula wherein the angle are on the numerator and then the side is in the denominator, or the reciprocal. So let us now discuss on how to solve this formula or how to use this formula. So suppose we are given this triangle and we are asked to solve for the unknown sides and angles of the given triangle. So notice here that the given triangle is an acute triangle wherein we don't have any right angle. So we will now use the law of sine in order to solve this triangle. So in this example, we are asked to solve for all the unknown sides and angles. So the easiest thing that we can solve here is the angle first. So we are already given two angles, A and B, and we need to solve for angle C. We all know that a triangle or the sum of the angles of a triangle is always 180 degrees. So in order to solve for C, we will just add angles A and B, and then we subtract it from 180. So our solution will be like this. So C equals 180 degrees minus the sum of A and B, which are 63 and 49. So solving for that, we'll get 68 degrees. So meaning angle C is 68 degrees. So every time that we are solving for a missing angle and we already have two angles given, we can just subtract the sum of the two angles from 180. Because remember, the sum of the angles of any triangle is always 180. Now let us solve for the missing sides. So here, we are only given side A, which is 14. So this is side A. And we need to solve for sides B and C. So here, the given angle is A and side A. And then we are given angle B, which is 49, and we need to solve for side B. So with that, let us use the pair of A and B using the presented formula earlier. And that will be sine A over A equals sine B over B. And then let us just substitute the given values from the given triangle. So we'll have sine A, wherein angle A is 63 over the given side, which is 14, equals sine B, which is 49, all over the unknown side, which is B. And then we can just cross multiply that to continue the solution. So with that, it will become B sine 63 equals 14 sine 49. Now, since we want to solve for side B, we'll just divide both sides by sine 63 so that our solution will be like this. So in order to solve for B, we'll have B equals 14 sine 49 over sine 63. So let us input all those values in our calculator to solve for side B. So therefore, B can be estimated as 11.86. So let us write our answer here for side B, 11.86. Now let us solve for the last side, which is C. So again, let us use the original given, which is angle A and side A. So with that, we can just use sine A over A equals sine C over C. And then again, let us just substitute the values given in the triangle. So we'll have sine 63 over 14 equals sine 68 over side C. So when we cross multiply, this will become C sine 63 equals 14 sine 68. Again, we need to solve for C. We will divide both sides by sine 63. So that our solution now will be C equals 14 sine 68 all over sine 63. So that side C is estimated as 14.57. So let us just write our answer here. It will be 14.57. So basically, that is just how we use the law of sine in solving oblique triangle. Law of sine is just one way to solve oblique triangles because in some cases we cannot use law of sine, and we will going to discuss that formula next meeting. Now, let us continue our discussion. Okay, so let us now use the law of sine in solving problems like this. So reading the problem, we have point A, which is shown in the illustration. The angle of elevation to the top of a tree is 38 degrees. From point B, 25 feet closer to the tree, the angle of elevation to the top is 48 degrees. How tall is the tree? So notice that there are two triangles that you can see here. We have triangle ABD and triangle ACD, wherein triangle ABD is obtuse triangle and triangle ACD is right triangle. So to solve this kind of problem, let us solve first the obtuse triangle, which is the triangle ABD. So to solve that, we need to find the missing values for ABD. Let us find first angle B here. Remember that for every straight line, that is equivalent to 180 degrees. So if one side is given, which is 48, we can find the other side by subtracting 48 from 180 because remember they are supplementary angles. So 180 minus 48 will have 132. So meaning B is 132 degrees. And then let us solve for this angle, angle D. So again, a triangle is 180 degrees. We already have 38, which we already have 132, and we need to solve for the remaining side or remaining angle. So with that, we'll just subtract the sum of 38 and 132 from 180. So when we add 132 and 38, that will be 170 degrees. So 180 minus 170, therefore this angle is 10 degrees. So after we find the values of the angles, we can now solve for the missing side. And to do that, we need to solve for the hypotenuse of the right triangle. Now let us just name it as side A. So to solve for A, we can use the angle A and side A, which are opposite. And then we can also use D angle D and side D using law of sine. So doing that, we'll have sine 38, which is angle A, over A, which is the hypotenuse of the right triangle, equals sine 10, which is the angle D, over the side opposite of it, which is 25. So when we simplify this, we can say that A can be solved by 25 sine 38 all over sine 10. Again, A is equal to 25 sine 38 all over sine 10. So finding the value of A, we'll have, again, that's 25 sine 38 divided by sine 10. So that side A is approximately 88.64. Okay, so that's 88.64. So let us write it here. Okay, so that's 88.64 feet. Now let us focus on the right triangle. So here we are now given 48 degrees and we want to solve for the height. So since we now have a right triangle here, we can now use the formula that we have in solving right triangle, wherein the height is the opposite side from the given angle, which is 48. And then we already have another side given that we solved earlier, which is the hypotenuse, which is 88.64. So now we have the given side, which is hypotenuse, and we want to solve for the opposite side. So from there, using the formula in solving right triangle, we can use again sine to solve it. So that our solution will be sine 48 equals opposite, which is unknown, which is h, over the hypotenuse, which is 88.64. So solving for h, that will be 88.64 sine 48. So that h is approximately 65.87 feet. So we can now write our answer here. That's 65 0.87 feet. So this problem can be solved by combining two different solutions such as law of sine and solving right triangles. So whenever you encounter this kind of problem, you can just follow the solution that we have here. So that is how we use the law of sine in solving oblique triangle. So next meeting, we will continue the discussion by discussing law of sine, but ambiguous case. So that's all for now. Thank you.